All right, so we are here on 1C.11. It is two parts, part A and part B. Sometimes I say part 1, part 2. Who knows what I say? I'm pretty sure on your paper I wrote part 1, but you know what I mean? Same thing, okay? So it's a two-part, and for this one, because it is two parts that are very different, you actually have a part 1 and a part 2 homework as well. The homework is separate for 1C.11 because the concepts are drastically different, okay? So with that being said, we're going to be, in this lesson, our goal is to fine tune our techniques for graphing rational functions, like making sure that we can break down and analyze all pieces of the rational functions. And so when we're talking about writing equivalent representation of polynomial functions to analyze, what that means is that you're simply writing it in factored form, okay? So when they tell you to write equivalent representation, it's asking you to write it as a factored form. So your equivalent is between your standard and your factor. Does that make sense? Okay. So if on the test it says what is the equivalent form of this, it's asking you for either the factored if it's giving you the standard, or the standard if it's giving you the factored. Okay. So in this case, we are given what form first? The standard form. So we're given the standard form of the polynomial, which means to find its equivalent representation, we're going to have to factor. I didn't want to write anyway. Okay, let's try right again. All right, there we go. So this is our beginning. I was trying to write standard. There we go. So we're going to factor. Anytime you're factoring, the very first thing you should do is ask yourself, is there a GCF? Is there a GCF? Yes. What's my GCF? X. So I'm going to factor out my GCF. When I factor out my GCF, I'm left with, exactly. Remember, your GCF is like an 18-year-old getting kicked out the house. They're still part of the family. They just live outside of the house. Okay? So now I have that. Then the second thing you're going to do is determine, is this a grouping, simple factoring, or a complex factoring? It is simple because of what? It's simple because your leading coefficient is 1. And because you can ask yourself what multiplies to give you negative 15, but adds to give you negative 2. So we're going to simple factor. And what are my magic numbers? 3 and negative 5. Do we all agree?
Yes.
Negative 3, negative 5 times positive 3 is negative 15. Negative 5. Who are you talking to? So we have x minus 5 and we have x plus 3. So this would be our equivalent form of our y. Okay. You want the equivalent form because once you're in the equivalent form, then you can create sketches of important things. Does that make sense? Okay. So now you can create a sketch because this would be something that's on Nevaeh. This would be something that would be on the non-calculator part, okay? So when you are looking at this, you can find out all the different things that you need to know. You know, I'm gonna let y'all finish. Okay, I'm gonna let y'all finish since it's more important. So that's why I said that you should probably move to that table because you are a distraction rather than an invisibility. Okay, I don't mind you being here, but you cannot distract. All right, so starting off, we know that our y-intercept and our x-intercept are at the origin. That's because our first factor is x equals 0. So you have your factors. From your factors, you're going to find your zeros. Now I can find my zeros. Your zeros are always going to be what would x have to be to make it equal to 0? So we have x equal 0. We have x equal 5. And we have x equal negative 3. So I have zeros at negative 3. I have zeros at 0. And I have a 0 at 5. Okay, from there, creating your graph, you then are just going to use your knowledge of polynomial functions. What is my behavior of this polynomial function? So what are your end behaviors that are taking place? So as x goes to positive infinity, what is my y doing? It's increasing. It's also going towards positive infinity. Why do I know that? Because my leading coefficient is a positive, okay? And therefore, it's odd. So as x goes towards negative infinity, my y should be doing what? Going to negative infinity because they're opposite behaviors. That helps me establish what type of graph I should sketch out. So my graph would be doing something like pretending that that's a very curvaceous situationship there. And that would be my sketch, applying all the laws that I learned, all of my vocabulary, all to one. Again, the goal would be able to do all of this without a calculator, without the calc. Okay? If you cannot do polynomials, can you do rationals? If you can't deal with a polynomial, can you deal with a rational? No, you're cooked. Exactly, because rationals are made up of two polynomials, one in the numerator and one in the denominator. So if you can't do a single polynomial, what does that mean for your rational game? You're in trouble. Okay, so please, please, please make sure you understand and ask all the questions. It's the exact same thing, okay? So next, we're going to look at it from a rational one. So here you have f of x equals x squared minus 16, and you have x squared plus 3x minus 28, okay? I chose this example because it also is an example of another factoring skill that you should remember. The factoring skill that we need to remember for this problem is called, anyone? Difference of two squares, okay? Yes. So this is an example of difference of two squares. What that means is that you have two perfect squares that are being subtracted from one another. When you have two perfect squares that are being subtracted from one another, remember that was our a squared minus b squared, and they would factor out to become a minus b times a plus b, right? The square root of a minus the square root of b times the square root of a plus the square root of b, okay? This is another common factoring technique on the non-calculator that you are expected to know and be able to identify, okay? So when we look at this one, we're going to go ahead and factor using difference of two squares. So we have f of x equals the square root of x squared is x. The square root of 16 is 4. So x minus 4 and x plus 4. Okay. Our denominator is a simple factor. It's a simple factor because our leading coefficient is a 1. Okay. On your non-calculator part of your test, they're either going to be a simple factor, difference of two squares, grouping, or it's going to be a complex factoring that you can do with Xbox or using the quadratic formula, okay? It will be smaller numbers so that it's something that you can manipulate and underneath that 2-minute time clock. Does that make sense? But it's going to be your job to know when to use it, okay? So this is simple. So it multiplies to give me negative 28, but adds to give me 3. 7 and negative 4. So my factors are x plus 7 and x minus 4. Once I'm in this factored form, like we learned in our previous unit, I should be able to identify my wholes and my asymptotes, correct? So my wholes are what? Where's my whole at? At x equals 4. And where's my vertical asymptote at? X equals negative 7, okay? So far, as you can see, is the first part of 1C is just strictly review of things you should already know. Does that make sense? Okay? So it shouldn't feel like, oh, I've never learned this. Then what did we just test over? I don't know. Okay. All right. So with that being said, guess who's about to do example number 3? You are. Okay. So for example number 3, you're going to go through the whole steps of finding everything. Okay. Because our end game is polynomials are great, but we're also focusing more so on rationals. So I'm going to stop talking. I will not help you. You will help each other in your groups. Okay. Ask questions, support one another, and go. All right. So let's talk about what you should have gotten. And so on here, let me delete the other writing so you can clearly see what I wrote. Well, you know what I mean. All right, so your factored form should have been x plus 4, x plus 3. In the numerator, x minus 2 and x plus 3 in the denominator. You have x plus 3 in the numerator and denominator, so that's going to be our whole, right? So we found our zeros. Your zeros, what's left in your numerator? Left in my numerator is x plus 4, which is my zeros at. X equals -4. Find any values of Rx that has a hole. My hole is at -3. You take that value, you plug into your reduced equivalent form, and that's how we get the -1/5. Your vertical asymptote is what's left in your denominator. What was left in my denominator? X minus 2. Your horizontal asymptote is based off of your reduced form. What would be my leading coefficients is 1 and 1. So I would have y equals 1. And then your domain is after you create your sketch, you read it from left to right. So from left to right, I am going from -infinity up until -3. And then I go from -3, then from -3 to 2. And then I go from 2 to infinity. Okay, that is what you should have gotten. And this is where we're going to pause. We may or may not finish this all because it's technically just a review. And so it's just us diving a little deeper into the things. So you technically do not need your notes to do the start of the assignment. Does that make sense? Because all part 1 is a review of 1B concept. Okay. And so I will post the remaining parts of part 1, and you can look through and fill in on your own. Got it? All right.